Thank you for joining our session. So my name is Kyungjin Kim, and I'm Senior Applied Data Scientist at dunnhumby. And today we are going to talk about identification of customer behavior attributes through topic modeling. So this is our agenda today. So we are going to talk about how we applied topic modeling to customer transaction data of hypermarket retailer. So we are sharing two applications, one for basket level document and the other for customer level document. Through this analysis, we identified customers' trip missions and customer behavioral attribute and generated customer panel. First, let us introduce dunnhumby briefly. dunnhumby is a customer science company with global presence. We have 78 retail clients and more than 1,200 CPG clients all around the world. So we help them build customer-first strategies with data science solutions. So for retail clients, we provide solutions for different functions, including merchandising, marketing, and operations to create customer loyalty, improve efficiency, and drive sales. And for CPG client, we provide solutions in various areas such as customer insights, assortment, promotions, and media. So we like to start with defining our business problem. So in retailer transaction data we handle, there are billions of baskets. These data give us a variety of information, such as what people buy, when they buy, where they buy, etc. What can retailers do with this vast amount of data? In the world of data flooding, understanding what drives basket and customers is key to success in retail industry. However, it is not a simple task to accurately define common behaviors for billions of baskets and millions of customers. One of the retail clients we are working with have 6.5 billions of baskets annually. It is almost impossible to label or classify every basket manually. If we want to classify basket with some rules, any knowledge or reference need to be involved. This may carry bias or misconception. Unsupervised learning can be a great way of identifying meaningful patterns of this type of problem when we don't have or we just don't want to use our prior knowledge on how to classify baskets or customers. In this session, we would like to share how we apply topic modeling, one of the unsupervised learning techniques, to understand retail baskets and customers. So in the first part of presentation, I'm sharing how we used a topic model for basket level documents. One way of understanding customers' shopping basket is to classify basket into a number of missions by identifying customers' reasons to visit a store and shop. Customers usually have a primary reason to visit a store, and this determines what categories and items they purchase. We call this reason shopping mission or trip mission. To understand missions at dunnhumby, we commonly create trip mission segmentation to identify common missions across basket and classify each shopping basket into one of the missions. So this is a basket level segmentation that ties in multiple customers' needs within a basket. This segmentation can be used in various ways in retail business. Retailers can use this framework to diagnose drivers of business performance, to review price, assortment, and store experience through the lens of each mission, and also to tailor messaging relevant to specific missions. To build trip mission segmentation, we first identify what different need states customers have because we see missions to be accomplished by fulfilling different need states. And then we classify baskets into meaningful number of missions using need states data. Uh, at dunnhumby, we have used topping modeling as a way of identifying underlying themes in large grocery baskets. However, a topping model was originally developed by a text mining tool and has been widely used to find hidden topics that best describe a collection of documents. This model finds topics using words in a document. A specific topic tends to be associated with specific words. For example, data science topic has high association with words like machine learning, computer science, coding, etc. If those words appear frequently in a document, one is likely to classify this document as a data science document. In the same way, a topping model identifies topics using frequency of words in a document. So this model enables to understand a large collection of documents in a systematic way without prior knowledge or input. So dunnhumby internal team came up with a clever idea of employing this topping modeling to retail transaction data. They employed topping modeling to identify topics in billions of baskets. Then what would a topic indicate in this retail context? According to the previous research, basket topics indicate that human concepts are primarily centered around goals and interactions. For example, when customers shop an egg, they think it as a breakfast item or ingredient of something else like baking. They don't tend to think an egg is laid by a hen or a shape of an egg is oval. When they shop, they view items in the context of achieving some goals in their mind. Therefore, basket topics can be considered need states of customers which are satisfied by shopping a set of products. So egg can be identified as one of the breakfast need states with other items such as milk and cereal. So we employed topping modeling to identify need states, and they are used as input to identify missions across different baskets through clustering. Uh, let's get into some details. In topping modeling, each topic represents a set of words, and the goal of model estimation is to map all the document to the topics in a way such that words in each document are mostly captured by those imaginary topics. So after model estimation, each document can be described by a distribution of topics, and each topic can be described by a distribution of words. In retail context, customer shopping baskets are treated as documents, and individual products are treated as words. So as shown in this figure, we have information about each basket. We know what products are contained in each basket. Topping modeling enables us to identify basket topics by analyzing what products are purchased together. So we look at what products appear in the same basket frequently. And these basket topics can be seen as customers' need states. So each need state is a mixture of products where each need state has a weight associated with each product. So in this example, breakfast needs have high weight on milk, bananas, yogurt, and cat product needs have high weight on cat-related items such as cat litter, cat treat, and cat food. So after a model is built, each basket can be represented with probabilities of being tagged to each need state that are used as features for clustering in the next step. So yeah, going back to this example, basket A has higher probability on breakfast need states than school lunch need states because it contains products that have high association with breakfast, while basket D has higher probability on school lunch than cat products because the basket contains products that fulfill school lunch need states. Okay, then how we determine whether the topics are good? Topics can be evaluated by three criteria: coherence, distinctiveness, and credibility according to the previous research. This means topics should make sense, be unique, and consistently appear across multiple posterior samples. Coherence is a measure of topic interpretability. For example, pasta and pasta sauce can be easily associated with one topic, one need state, with pasta cooking. But pasta and sugar don't seem to serve a specific need. In this case, this topic is inherent, not coherent. Coherence can be evaluated by experts or consumers, and according to the previous research, human judgment on topic coherence tend to correlate it with NPMI, normalized pointwise mutual information. So instead of relying on experts or any group of people, we can use NPMI to measure coherence. And next, distinctiveness is a measure of semantic dissimilarity within a single posterior sample. So pasta cooking topic is distinctive from dog product topic because pasta cooking has high association with pasta and pasta sauce, while dog products topic has high association with totally different products like dog treat and dog food. The score for distinctiveness is calculated by getting minimum cosine distance between one topic and any other topic in the same sample. We find the closest topic in the same sample to this focal topic. If the closest one is far enough, we can say that the focal topic is distinct. This score would give us an idea of combining topics or re-evaluating the number of topics. Lastly, credibility is a measure of semantic similarity among posterior samples. Recurrent topics tend to appear several times across different posterior samples, showing higher credibility. In this example, the examples in the table, pasta cooking and dog products appear in different samples, indicating they have high credibility. On the other hand, Halloween topics only appear in one of the samples, showing lower credibility. Score for credibility is calculated by getting maximum cosine similarity between a topic and all topics in a different sample. We find the closest one to the focal topic in a different sample. If they are close enough, we can say this topic appears in both samples. Hierarchical clustering can be also used to aggregate topics from multiple posterior samples. A recurrent topic would be associated with a cluster with large cluster size, and we can keep those recurrent topics in our model. So topics need states are created around products frequently purchased together. These group of products represent one theme and potentially fulfill a specific customer need. Here are some actual example topics from our analysis. These are top 8 product groups for each topic. The first topic, which we named fresh vegetables, contains bell pepper, cucumber, green onion, celery, and lemons. These are fresh ingredients for many different dishes, and this was identified as a dominant need state in scratch cooking mission. The second topic has various personal care items, including deodorant, body wash, and toothpaste, which fulfill customers' need around hygiene. The last topic is all about dog-related items, such as dog food, dog treat, toy and training pads. The second and third topic were also identified as a dominant need states in different missions. So after estimating a topping model, we ran clustering using each basket's weight on each topic as a feature. Baskets that have similar distribution over topics are likely to belong to the same cluster and form one distinct tree mission. As it is unsupervised learning, we needed to give some proper names based on profile of each cluster. So we look at various metrics such as size of clusters, spend per basket, quantity per basket, over-indexed categories, seasonality, and some customer profile such as price sensitivity and retailer loyalty. These are the missions we identified from clustering for one of our retail clients. These missions are accomplished through multiple need states, and each tree mission has distinctively dominant needs. For example, in scratch cooking mission, topics such as fresh vegetables, baking, taco cooking ingredient topics were dominant. On the other hand, in cooking on a budget mission, topics such as hot dog, shelf-stable foods, no-cook dinner item topics were dominant. Like this, each mission is linked to some distinct need states that are fulfilled by a specific set of products. Retailers can use tree mission for a variety of purposes. First, this can be used as KPI reporting. This can diagnose drivers of business performance, which missions drives growth of sales and loss of sales. In addition, retailers can learn trend by tracking missions over time. Next, we learned that the size of each mission varies by region. So stores can be grouped based on similarity of mission size, and this can be used to differentiate assortment or store layout across regions. Lastly, this segmentation can be used for promotion planning. Retailers can create a bundle of key items that make up a specific mission in order to promote that mission. This can also plan seasonal events using tree missions. They can also plan seasonal events using tree missions, since some missions are highly seasonal. So far, I shared how we apply topic modeling to customer retail transaction data to build basket segmentation as a way of understanding customer shopping missions. In the next part, Iain is sharing how we use the same technique to understand customer behavioral attribute. So I hand over to Iain.
Awesome, thank you, Kyungjin. So now that Kyungjin's talked through the understanding of how we might use topic modeling at the to build out trip missions, I'm going to talk through customer topic modeling, which is really just a modified approach to the document generation process. Oops. So as we started thinking about transitioning over to this customer document, we're kind of keeping in mind some of the learnings that we've had across previous iterations. So we've seen Kyungjin's approach to trip missions. There was also kind of a previous approach prior to that that was looking at sort of the basket level at sort of the product ID level as opposed to that product group level and looking a little bit more granular. So kind of seeing these, we had this idea of what if we were to translate that approach at the basket level to the customer level, and how we might see different sorts of topics emerging based off of the definition of a document. And so the way that we kind of thought through this was that previously those documents were really defined as an unordered set of products within a basket or product groups from the trip missions approach. And transitioning from that towards a customer document that's really a number of different basket documents. If you think about a year's worth of data, so a year's worth of customers' baskets, and we're going to kind of smash all of those together to create a single document for each customer. And what that's going to do is it's going to create a much larger and less focused document. And with these larger and less focused documents, we were really kind of intrigued on, are these going to be interpretable? What sorts of topics are going to be appearing with this, given that we have sort of this less focused approach? And when I say less focused, what I mean by that is previously with the trip missions approach and even the prior basket approach, we would see things that are very specific to like a mission or a need state kind of appearing. And with this, given the number of distinct visits, we expected to see a much broader types of topics appearing. And so we were really kind of interested to dive in it and see how that would be different. So the way that we kind of thought about this was that there were three distinct levels that we were looking at and playing around with. And depending on the use case, we might be able to come up with a different definition for the document or the word that could be used to influence the topics that we're actually going to find. And so that original approach, which Adam Hornsby and co had kind of worked through, was around distinct products in a basket. It's very much granular topics and product ID. Kyungjin walked us through the trip missions approach earlier, and this customer approach, where what we were starting to find is that these topics are a bit more conceptual in nature. So they're not necessarily as focused, but they're a little bit more broad. And some of them are a little bit almost attributes of customer behavior. A few kind of other differences as we kind of transitioned across these were that the original approach was using something called Gibbs sampling as sort of the posterior inference algorithm. With the trip missions and customer approach, we transitioned towards an online variational Bayes approach, which gave us some additional dividends in terms of speed that we were able to use to great effect. And so with that change in how we thought about the document, we were able to kind of come up with some initial customer panels. And when we did this, we thought about, okay, we've kind of built these customer topics where a customer is this distribution across topics, where they have a likelihood of belonging to each topic. But from that, we want to understand what topics really are attributes of that customer. And so we had the idea of creating customer panels, which we kind of considered as an attribute of their shopping behavior. And as you might imagine, there are a number of ways that you might be assigned to a panel. And those could be things like looking at the optimal number of topics for each customer. So looking at the document topic weights and understanding, hey, there's this kind of inflection here where after a certain point, the weight's significantly decreasing. So maybe these topics are a bit less important to this customer. And beyond that, you would have approaches like simple thresholds, rules-based approaches, top-end topics, and so on. But we really found that optimal number of topics for each customer was the primary approach that we were going to go forward with. As sort of an example of this, because it is slightly different from the example that Kyungjin shared earlier, we have this customer where the document is what they've bought across this entire year. And so with this, we can have things that are appearing multiple times because they bought it in multiple baskets. So an example of that within this is cat food, where customer A has purchased cat food in multiple trips. They've also purchased a number of other products like organic bananas, almond milk, sparkling water, etc. A number of those products are going to be associated with this sort of healthy living topic, and that topic is going to receive a high document weight for this particular customer, and then so on. And the way that we've kind of split this out for this particular example is if we've had this sort of optimal number of topics, and we found that for this particular customer, it's maybe 2 topics. And so from that, we can see that this customer would be assigned to the healthy living panel and to a cat owner panel. They would also have, some additional topics that there may be potentially slightly more inclined towards, but maybe aren't included. And then they'd have topics like baby or frozen that they might not be associated with. And so from that, you might be kind of asking, why a customer panel? And the reason that we've really gone with customer panels as opposed to like a pure segmentation or just a single topic per customer is really that we want to enable customers to belong to several different groups. And that was fairly important to us because we felt that customers are exhibiting multiple behaviors at the same time that are relevant to multiple topics. And we wanted to allow them to be tagged in multiple different customer panels and not sort of pigeonhole them into just the one that best described them. And these customer panels, you might imagine that there are a number of different potential use cases, but some of the primary ones were looking at customized analytical deliverables. So if we wanted to do sort of a deep dive that might involve one of these panels, looking at sort of migration between panels or customers that are kind of transitioning between panels potentially. Understanding some of the trend analysis. So if we sort of look and build different models at different periods of time, are we getting those same coherent, distinctive, credible topics, or are we seeing different topics that are kind of popping up? And that could be kind of a different way of looking at it that might be interesting. You also have your basic profiling as well as things like media targeting or measurement for specific groups of customers. And a second question that I think a lot of people might be thinking is, some of these panels that you've talked through, things like cat owners, are not terribly difficult to find, and there might be simpler rules-based methodology approaches that might be able to capture that group. For example, with cat owners, you would expect that if a customer is consistently buying cat products over a year, they're likely to be a cat owner. That is true, but the reason that we're really thinking about topic modeling in this instance is that we want to understand what topics are best describing customer behavior, but we don't want to necessarily require prior knowledge of what panels or topics we're expecting to occur. And what I mean by that is that generally we'll hear from merchants that there are a number of different behaviors that they're expecting within their category. And while that is, really important in building our understanding of how customers are shopping there, we don't necessarily want our prior knowledge or misconceptions to lead to any missed opportunities or lead us to not look at a specific way that customers are shopping. And so this approach really enables us to capture those, even if we aren't necessarily looking for it in the first place. And the final piece and a reason why we kind of like topic modeling for this use case is that topics are dynamic, and we can check them across a number of different time frames. We can look at different levels. And what I mean by different levels is really that we can look at this at an overall level, and that's where we've kind of been focusing on so far. And you might see things like healthy living, cat owners, baby, frozen, etc. But you can also focus in on a smaller area, a department or a category, and filter those customer documents down to that specific area. And in doing this, you can find sort of different types of topics. As an example, if I were looking at something like a produce department, I might be able to find topics around organic items or value-added items, things like cut fruit, and so on. If I were looking at a snacks type area, I might be able to see different customer behaviors, such as like preferences for spicier foods, preferences for salty or sweet, and so on. So this kind of approach is a bit dynamic and can be scaled or kind of drilled down in specific areas. And that enables us to be a little bit more flexible as well. So the next kind of question and kind of thought that many people would have is, what types of customer panels can we find? And from our experience, we've found a couple of specific types of topics generally, and those tend to align with things like preferences. And by preferences, this would be something like healthy living, where they're tending to purchase maybe healthier type products, It's more of like a lifestyle type thing or a preference of the types of products they like to purchase. The second sort of behavior pattern, kind of creating a topic, will be something around needs. And this would be kind of like the cat owner example that we talked through, potentially the baby as well, where if you own a cat or if you have a baby, you're likely to be purchasing those sorts of products. So it's more of a needs focused pattern. A third type would be something around location. So an example of that would be like a suburban family customer panel, where the topic representing this is kind of associated with words like grills or charcoal for grills or bait for fishing, lawn and garden, lots of sort of GM type products that are focused a little bit more on the outdoors, in addition to just your general food type products. Beyond that, there are other types of behavior patterns that could be due to things like demographics, et cetera, that can also pop up from time to time. And then at a lower level, I talked about this a bit on the previous slide, but you can filter down to specific categories and you can find similar types of behavior patterns at a category or department level that can help inform insights within that area. As kind of an example, because I think it's kind of valuable to see, what one of these panels is and how it's represented. An example of that would be this healthy living customer panel, where a healthy living customer spends significantly more than the average customer over this year period. Their basket is going to be larger, both in terms of sales and in terms of units. They're going to significantly over-index on areas and channels like pickup and delivery. They're more likely to shop earlier in the week and earlier in the morning. More likely here, I mean more likely than the average customer. And in terms of representative words for this sort of topic, you would see things like organic bananas, branded unsalted butter, baby organic arugula and spinach, organic brown eggs, avocados, etc. And with this panel, you can do a number of different things. You could potentially target them for media. You could potentially try to understand, I've made this change. How does this impact the healthy living customers? You might imagine, I'm thinking about a new product. I might look at which stores have a greater percentage of healthy living customers where I might want to introduce this product, things like that. And so as we kind of think about the outcomes of this sort of area of study and what we've done so far, we've created some initial panels at the overall level that are really a proof of concept. And those are available for custom analysis to answer relevant questions internally. And I kind of talked already through some of the use cases like migration, measurement, et cetera. And then we've tested a number of additional quote unquote custom customer panels. Those are those more focused level customer panels. And those can be kind of developed and built ad hoc. So that if we have a specific use case, a specific area of interest, we can kind of really dive in and sort of try to derive insights and understand how customers are shopping that specific area. And then finally, as sort of a next step, we had identified potentially artificial augmentation of documents as an additional avenue for future research. And by artificial augmentation, I'm really thinking around, right now we think of a customer document basically as this unordered set of basket documents, more or less. And that contains a significant amount of information, of course, to create these different topics. Additional pieces could be added into that, things like the skew of a particular document towards price sensitivity, specific tags for different types of products potentially that we want to maybe weight a little bit more in the development of those hidden topics, and so on. And those are kind of something that we're thinking about and trying to see, does this actually have an impact on the topics that we're able to glean from this, or is this something that maybe we're already gleaning the insights from this, from what we have currently?